Okay, so today I'm going to talk about, it's just going to be an add-on from talking about drawing Lewis structures. So this should be pretty short, definitely shorter than the actual Lewis structure video. But what we're going to talk about is drawing Lewis structures of polyatomic ions. Polyatomic ions. So what's important to understand is a polyatomic ion is a molecule, a covalent compound that has gained or lost electrons, right? So like for example, SO3 is a molecule, but sulfate is a polyatomic ion. So drawing Lewis structures for polyatomic ions is pretty much the same as drawing Lewis structures for molecules, for neutral compounds. There's just two alterations you have to make. Just two changes. The rest is all the same. The first change you have to make is you have to you have to adjust the number of valence electrons on the structure for for the change in the number of valence electrons because of the charge. So when we go to add up the number of valence electrons on sulfate, or actually, I'm sorry, this is sulfite, the way I wrote it, sulfite. We have 6 from the sulfur, right? We have 18 from the 3 oxygens, 6 times 3. And then the -2, does that mean that we have 2 more valence electrons than we otherwise would, or 2 fewer? Remember, electrons are negatively charged, so it's 2 more. So I have to add 2 electrons on, so now I have 26 electrons instead of 24, right? So that's the first adjustment. And the other adjustment comes at the end. So from this point on, just draw the structure as you would normally, right? So I'd have sulfur in the middle, oxygen, 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 right? And so I'm going to put 2, 4, 6 valence electrons total. 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. 26 electrons total. I am out. Does anyone need any more electrons? Is everyone happy? Everyone appears to be happy. The last thing, sorry, I'm just going on and making the last change. So this structure is good. The only thing we have to do is, remember when I talked about drawing Lewis structures for ionic compounds, if you have an ion, we put brackets around it and then the charge. So those are the only 2 changes we have to make for polyatomic ions, is we have to change the number of valence electrons that we put on the structure and then put the brackets in the charge. So let's try a couple more. So we should try, let's try NH4+. Let's try ammonium. So NH4+. And so what you would do, so go ahead and pause it and try to draw this. And then come back. So what we're going to do is we're going to put N in the middle. Actually, let me add up the number of valence electrons first. So nitrogen has 5. Each hydrogen is 1, so there's 4. And then the plus means we actually take 1 away. It's a lost 1. That's a total of 8. So we have hydrogen, 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 hydrogen. And so we have used up 2, 4, 6, 8. Every hydrogen is good. Every nitrogen is good. All we have to do is that. Okay, let's try carbonate, and then we'll kind of be done with it. So carbonate is this. So I've got 4 electrons from the carbon. Oxygen, each one is 6 times 3 is 18, plus 2 is 24. So carbonate is simply this. And then what I'm going to do is I've already used up 2, 4, 6 valence electrons, 8, 10, 12, 14, 16, 18, 20, 22, 24. And now, is everyone happy? No, carbon only has 6 valence electrons, so I just need to make a double bond. Important, remember to erase the lone pairs when you make double bonds, and then put the brackets in the charge, and that's it. And that is drawing Lewis structures for polyatomic ions.